Our next partner was already mentioned in the talk. Martin from dNation, the CEO of dNation, will give you an input on how dNation works with SCS and our community.
Good afternoon to everyone. My name is Martin Pilka. I'm CEO of company dNation, making cloud easy. And today I'm going to tell you about SCS and dNation and what we have accomplished together in the last 2 years. So, as some of you may know, the dNation name, the D in our name stands for 2 things. The first thing is development, like software development, and the second is DevOps, like DevOps engineering. So we are both software engineers and DevOps engineers at the same time. That gives us in a good position to actually apply for SCS standards, which we did, and we won 3 of them, namely Container Registry, Health Monitoring, and Networking. So right now I'm going to tell you about Container Registry and what we did in this particular tender. So what was the challenge here? Well, there was a deployed solution and it was based on Harbor. However, it was outdated and it was running the old version of Harbor. So it didn't scale very well. It didn't contain any security features. So, for example, automatic scan for known vulnerabilities. And what was the solution for that? Well, obviously we need to migrate. So we did successful migration to the new Harbor version in May 2023. And we did it via a lift and shift approach. We deployed latest version of Harbor with high availability features of fundamental components. We did storage migration from PV, which is persistent volume, to the object storage. And we also implemented the backup, which was done by Velero. All this is described in the blog with the name SCS Container Registry Migration and Upgrade, which has been written by our CTO, Maciej Feder. As a part of it, there was an additional functionality deployed, proxying and caching major repositories, for example, Docker.io, daily security scans with 3V security scanner, OIDC authentication with rate limit protection, automatic garbage collection and log rotation, storage quotas, webhooks, and content signing and validation. As with most of the code which we wrote for SCS, it's used also in our own infrastructure. So it is used in production by both SCS community and us. So when something gets wrong, we know about it usually before SCS and we fix that beforehand. As a part of Container Registry, we are also active in Kubernetes as a service, both version 1 and version 2. That's actually what is going to be the Monday's presentation at 3 p.m. About. We did integration with SCS Container Registry. We implemented cluster stack provider OpenStack and OpenStack plugin for CSCTL. In this particular case, the target platform was Hetzner, and we did multiple upstream contributions thanks to this work. The next project we've been working on and I would like to tell you about is VP12, Health Monitoring. The challenge here was that there was an existing blueprint monitoring script written in Bash. It did work. It did contain most of the functionality needed to test your OpenStack instance, whether or not it does work. However, it was difficult to maintain, and it was difficult to extend with new functionality, mostly because of Bash shell language limitations. So the solution to this problem was, well, we defined primary goal, which is automating the health monitoring of SCS infrastructure on OpenStack and Kubernetes. We did select appropriate tools for behavior-driven development, or BDD. BDD was part of the tender description, so we had to find the right tools for that. We did ADR, which is architectural decision record, and we considered multiple options. And we chose Behave as a framework for writing tests in Gherkin language, Python on backend, and BehaveX for generating reports. So all this became the part of SCS health monitoring framework, which covers functionality of the all monitoring script, and it does health monitoring of both infrastructure and Kubernetes layers. It is easy to scale and easy to onboard new developers. The next project I would like to tell about is VP04 networking. The challenge here was that encryption is not used everywhere in OpenStack. When OpenStack does talk to outside world, it does use encryption. The endpoints are protected by HTTPS. However, it's not the case when the internal components of OpenStack itself talk to each other. That might be an issue with sensitive applications. So what we did? We did end-to-end encryption between OpenStack internal components. The project is still running on. First, we had to identify those components. There are around 15 of them. Then we had to check whether or not encryption is supported by each one of them. If it is supported, well, it's quite easy. You just enable it. If it's not, it's getting harder because you need to implement that, and those components are written in multiple languages. So you need to go down and actually, in that particular language, add the support for usually libSSL library or something similar. There is over 20 upstream pull requests in Kola Ansible and related repositories. We did also proof of concept with Kola Ansible utilizing IPsec. Whole effort is obviously aimed to make OpenStack installation more secure. Then the next challenge was poor network scalability in OpenStack. When you have an OpenStack installation and you are keeping adding nodes, there is a certain threshold around 700 nodes when you hit slow network. And if you keep actually adding more, then eventually the network gets unusable. So how to get around that? Well, it turns out that actually there is specialized hardware which does contain hardware features to route packets. And there is an operating system or something like that called Software for Open Networking in the Cloud, or SONiC abbreviation. It's basically a firmware for this kind of specialized hardware which can help you to scale more than 700 nodes if you want to. So what we do is automated provisioning and management of SONiC devices and proof of concept for SDN network scalability and cloud interconnectivity. Next thing I would like to tell you about is SCS monitoring platform. Well, long before we started with SCS, we had this problem of monitoring our hybrid infrastructure. We have machines and clusters running at hyperscalers, mostly AWS, but not only. There is also some Azure, OVH. Then there is some rented hardware on-prem. Then there are some customers on-prem installations. So how do we monitor those? We needed some kind of unified view whether or not there is a problem in our infrastructure. Now, there are multiple ways how to do that. If you want to stick with open source, there are not so many choices. One of them is Prometheus, Grafana, and Loki Stack, which we took as a foundation, and we did what we call dNation monitoring. It's basically a set of dashboards which are specialized for certain purposes, mostly Kubernetes monitoring cluster. Then we added OpenStack instance monitoring, then VMs or physical hosts. Now, dNation monitoring is following very simple principles. We basically want to know each and every day whether or not we can go to lunch. Green means, yes, everything is fine, we can. Orange means there's an issue, but it's not an urgent one, we still can go, but then we have to have a look after we return. Red means no lunch today. We have to work until it's fixed. It is used in SCS for monitoring both infrastructure and Kubernetes layers. There is also integration of Alert Manager with Metrics Chat, which is used because metric is the protocol which is used by most of the SCS community, so we integrated it. It's used in production by both SCS and ourselves. This is how it looks like. The launch looks promising in this particular case. We are monitoring a single VM. We see that CPU and RAM and network are fine. There's an issue with disk. It's 85% utilized, space utilized, so it turns orange. If we do not do any action, eventually it will reach 90% and it will turn out red. So it's a very easy way how you can just by a simple glance at the screen see how are your clusters doing and whether or not there is an action item. Next thing I would like to tell you about is cooperation with partners we have met in SCS ecosystem. Well, SCS ecosystem is an amazing place. People are sharing information without any hesitation, like releasing their secrets, business secrets are similar. It's not so usual. So we are very happy to be part of it, that we can actually participate by our part and share knowledge together because, well, the market is huge. There is no need for a competition. We can cooperate. During our STS involvement, we have met several companies we have been very closely cooperating with. I will name some. Hopefully, I will not forget someone. Cloud and Heat, namely, we've been doing together VP12 and now VP10. Artcodix and Uhuru. These guys are running SCS-enabled installation on the bare metal. Artcodix is using Osism, Uhuru is using Yauk, but we still can share a lot of knowledge, operational knowledge, and we are talking about sharing the source code of services built on top of SCS OpenStack installations like relation database and similar stuff, Kafka, because we have customers and potential customers who do ask for that. So we are also going to support, also financially support OSBA upcoming organization called SCS Standards Forum. So obviously OSBA is also our partner. And that would be everything from myself for today. Thank you very much for your attention. If you have any questions, feel free to actually contact me after the presentation and have a nice afternoon.